So we worked on problems that deal with a specific type of equation that ask about at least one, and we approach this calculations from the point of view of complements. So let me check out a problem so we can refresh the ideas of this section. And I'm gonna maybe take exercise 17, odd numbered problem that could be good as a homework exercise. So we're in section 3.5, and they're trying to put blood samples, mix them all together. Why? Well, just, I guess, to save funds on the procedure. So they say they take blood samples from 3 people and they combine them all together, and their goal to see if the test is negative. They hope for that. But question here is find probability that a positive result is here. So they hoped to save and to see them all being negatives. But if you get a positive result in one of the samples, or in 2 sample results, or in all 3, then the whole mixture will be positive. So we're saying that probability of at least one, remember that statement? At least one, we want to be on the positive side, and at least one means either 1 or 2 or 3, and the complement will be none of them positive. So in other words, everything is negative. So it'll be like 1 minus probability that none of them are positive. And none of them positive, I can calculate much faster, because it means that we have probability of negative and another negative, and a third one is negative, right? So all 3 negatives, that's the only case when none of them is negative, because once we get a positive in this mixture, then that's it. The whole thing shows positive. So I want to make sure that all of them are negatives. So why do they care about this? Well, because it looks like the test of positive is not as likely. So since probability of positive is 10% or 0.1, it's more likely that the test will be negative, and that's why they trying to go for that option, because if more likely will be positive, then they would go with option positive. So it looks like they see that chance of negative, which is opposite to positive, is 90%, 10% positives. The remaining ones are not positive, so negatives. So looks like if they get probability of negative 90%, which is more likely, and another 90%, and another 90%, that's going to be the probability that none of them is positive. So it's something like 0.9 raised to the power of 3. So you subtract this from 1 and see what will come out. So this is the approach that they take in the exercises in the section. So I just want to use a calculator and subtract from 1.9, which is raised to the power of 3. Let me clear this a little bit. So we have this calculation going on here. It's 0.271, right? 0.271, that's our answer. Because again, otherwise I would have to get a probability that 1 is positive, and that could be either first or second or third. So that'd be a lot of work. That's the idea. So it's faster just to get compliments and be done with it pretty much right away. So that's what this section is talking about. And it also extends the story with more conditional probabilities. I guess this is a somewhat familiar table related to the Titanic data. And let me do one problem in here. So exercise number 19 that deals with conditional probability. It has a special question to find the probability that man given that person died. So to write this down, I put probability of a man, then for given we put a bar, and then the person died. So that's given, that's our conditional probability. So the way to approach it is always with respect to what is given. So what's given is that person died, sad, given thing. So now we're only dealing with a part of the sample which is given to us. So we already know where we are because they told us. We gave you the person died. So I can see that total here is 1360 and 104 and 35 and 18, right? So this is the total that I always put in denominator. So I no longer deal with entire sample. I'm given only that part, okay? Well, now here comes their question. Find probability of a man. So it looks like here's the part of our sample that relates to all the men, and that's 1360. So as usual, probability is a fraction. As usual, denominator is total, but now it's not the whole sample. Now it's only a part of the sample. And then I need to see the chances that this is a man. And well, looks like out of this entire group, I have some men, some women, some children, those I don't consider. They just want a part related to men. So that's what I put in my numerator. So now it's a calculator time, and thanks for already producing it. Very good. And let me do this with my calculator. So I divide 1360, right? And then when I put division by that 1360, I just need to keep on adding plus 104 and also 35 and also number 18. So again, advantage of this calculator is what you enter is what you see right away. So you can always utilize it. Yes, I highly recommend and kind of advertise this calculator. It's not because I benefit from this. No, it's because that in the later chapters, in such a chapter as 6, especially 7, we will heavily calculate, not like these fractions. We'll have a square root, something square inside some fraction. So this will be the best and the most convenient calculator, I believe, to use, and it'll give you nice expressions right away, so you'll be able to visualize them. So I put the link to it again in the chat, so you can utilize this calculator. Just get used to it little by little. Again, it's up to you which calculator you use, but you will see eventually that this is really a very convenient one. So we're done with exercise number 19. So how about if I try one more here with a conditional probability with word given here. So what about problem 21? Another odd exercise, supposedly from the homework. So let me try exercise 21. That says, what is the probability? Again, call it as P, that boy or a girl, so that's what we want to find, boy or a girl. And then they say word given, that someone had survived. So we have different given part in the sample. So I better highlight what is needed in here. So survived. Now it's a first row, right? We're here. And looks like this will be my denominator then. So let me put in denominator all the numbers for survivors: 332, 318, and also 29 and 27. Okay, so that's my total. Please notice it's completely different. And then for numerator, as you already noticed, it's just boys and girls. So that's the part, the last part of this group. Yes, yes, and that's 29 and 27. So we have this new fraction. So great, great that you're working on it. And let me also put this together. Please notice that in this calculator, I must use parentheses for numerator because otherwise I won't be able to divide sum of those two numbers entirely by my 332 plus, so the entire denominator. Keep adding 29 and 27. But once you enter this in, that's it. You got the answer. So it's 079 3, etc. So here is the answer. Anyways, conditional probability means that sample is shrunk. We got just small part than the whole thing. Well, let us move on to the new stuff. So what I want to do is skip section 6 of chapter 3. The reason is we always skip it. Turns out section 3.6 is what we don't worry about because it deals with producing our own experiments. So one needs to go out on the street and start picking on people, asking them all kinds of questions to collect data. I don't think it's very safe nowadays, so you probably don't want to do that. And turns out all the data we get from the other sources instead of creating our own experiments by using so-called simulations. So we produce the process. So I guess that's the part that we disregard. So we're going to move to the last section of interest in chapter 3. That's very interesting section. It deals with so-called counting various probabilities. So let me see how they approach this. And first of all, they introduce us with so-called factorial notation. So they say that if you have 4 factorial, you multiply numbers 4 and 3 and 2 and 1. So if you have 5 factorial, then you multiply numbers 5 and then 4 and etc. Just going down all the way to 1, 3, 2, and 1. And you can just multiply these numbers together, like 20 times 6, which is 120. So factorial calculations. It turns out that the calculator we have here has that special symbol factorial in it. So if I wanted to put 5 and then find that exclamation mark, which is called factorial, I need to select functions. And then you will see on the last row the factorial symbol. So you could just click on it and get that same 120. So there is a way to use calculator for these factorials. And of course, calculator gives you much faster results because let's say if somebody wants to find 20 factorial, then definitely to enter numbers 20 times 19 times 18, you see it takes a while, right? So you put dot, dot, dot all the way to 1. But with this calculator, all I can do is just click where the 5 is, delete it and put 20. So what is this? This is a huge number. It turns out that this number is 10 to the power of 18. So you need to move your decimal 1, 2, 3, 4, 5, 6, 7, 8 places. And since power is 18, you need to add 10 more zeros. 3, another 3, and another 4. This is going to be the number. So this 2 something. When you say, what is this number? Well, you can see what is that. That's like octillion or something like that. So it's a very big number that we don't even probably know how to name. So we just say it's 10 to the power of 18. So that's lots of zeros at the end of this big number. Turns out when you start multiplying numbers, they increase tremendously. Notice if I try to find the, say, 1000 factorial, 1000, the calculator is not going to be able to take it. So that's a limitation of the calculator. Well, because the number is huge. The number is huge. It's just not undefined. It's so many zeros that just might take a while to write. So, well, people can use so-called numeric processors. There are special computers with special programs that actually take those huge numbers, but there is no need for us to deal with those. That's why I guess we never encounter them. But I just wanted to show you that these calculators, they also limited in their abilities to calculate. Interesting. So anyways, this factorial symbol is being utilized in the section, and you can see there are interesting examples here that talk about 50 factorial. So there are some stuff in here. We'll talk about it next time. Today, my goal is just to introduce you how to work with a calculator. And it looks like in section 3.7, I just want to take a look at a few examples in here. So you could just start to get used to your calculator. And then next time we'll actually talk about them in more detail. So for instance, what if you want to find so-called permutations from 100, choose 3? What is this really equal to? Well, analogously to the previous calculations, so if I try to find the number of permutations out of 100 to choose 3, then this is what I need to enter into my calculator. So that's exercise number 4 here. And well, let's go to the calculator and select this number of permutations here. Notice that, again, I click on functions, but now I need to select a special symbol called NPR, which is the one here on the last row. So I enter this in the calculator, NPR. And then in the parentheses, so to get back to numbers, I need to go back to the main menu. That's where the numbers are. So I click on this main, and I just put 100 and then comma. Make sure it's in the parentheses. 100 and then comma 3. And then I close this parentheses. And there we have the answer. So it looks like we produced the number of permutations, which is 970,200. Well, what it actually stands for is if you have 100 elements and you want to select 3 numbers from those. So for first number, you have 100 choices. So if you have 100 elements, doesn't have to be numbers, but whatever, 100 people, then on the first position, you can put anyone from this 100 people, but then for the second position, you have only 99 people left. So you put only one different person in each position. So 100 choices for first, for next position, 1 less. And for the third position, again, 1 less because 2 people are gone. So notice that if you multiply these numbers all together, 100 and 99 and also 98, you will get that same number of permutations. So that's what this actually stands for, number of ways to select 3 people, different people, out of 100 positions. But again, we'll talk more in more detail about this next time. Today, I just want to get used to using a calculator. There is one more symbol here that we can put in the calculator. That's a number of combinations from 100, choose 3. And to calculate that, we'll need to, again, put this in a calculator. So I'm going to functions, just like we did before, main, remember, main, and then functions, right? So next to the permutations, looks like in this last row of possible entries, we have the permutations, factorial, and this combinations in between. So I hit this NCR, combinations, go back to the menu, and then have 100, comma 3, and get also some kind of number. And again, we'll discuss this next time. We'll look at particular problems, so you will see what this means, this number of combinations. So today I just would like to get used to these symbols. So maybe you can also try to calculate some type of a factorial. Let me just refresh your memories how we calculate those. So let's say to get 15 factorial, you could either multiply numbers from 15 all the way down. So you can go 15, 14, 13, all the way to 9. Or if this is annoying, which actually is, right? You just put 15 and then go to functions and choose factorial. and it will give you some kind of number. So 15 factorial is whatever the number is. So for a little quiz for today, I can ask you to do problem number 1. I think that'd be a good question to start with. So let's have number 1 for today's quiz. So please calculate 6 factorial. What do you think 6 factorial is? I also want to tell you that I recalculated grades for this class for everyone, and I have them all on the blackboard. So I updated grades. Some people still have the same exact grade, so I didn't update it because it's the same, and it's perfect if you have same grade, which is very good. But if your grade went down a little bit or up, well, then I changed it. And if it's a little bit lower than it used to be, then I always give opportunity to fix it back by sending me some even extra credit problems. So you could do some from this group of exercises with these combinations. So just calculate your exercises. I think they're very neat, right? Pretty short. So you can take advantage of this. I would recommend, but it's your choice. If you want to do extra credit, it's up to you. If you don't want to do it, if you're already fine with your grade. But anyways, your grade is on the blackboard. You can check it out. If you are not sure what it is or you want to discuss it, well, please talk to me at the end of class. I'm here. Just don't log out or put your question in the chat. Either way, you're just going to need to wait a little bit. And yes, input answer right where you put your question, but make sure you don't send it to everyone. Just send it to Alex, just to me, to one person. Once you send your answer to me, that's it. You are good to go, unless you have some other questions. So you can have a great rest of the day.